probability is here we will see probability, number of outcomes by total number of outcomes. Here number of outcomes, a single coin is tossed. If the single coin is tossed, we have two options, head and tail. So total number of possibilities is 2. Whether it is head, they are asking 1/2 is for head. If they are asking about tail, then also the probability is 1/2. So two options we have. Suppose two coins are tossed. If two coins are tossed, what we will write here? Denominator 4 options: tail, tail, head, tail, head, tail, tail, head, tail, head, head. So if they are asking anyone, the probability of getting pure tail means 1/4. Only tail, tail, like different combinations we are writing. So first we will see the example 1.1. In example 1.1, what is mentioned is example 1.1. In example 1.1, there is two options, head and tail. The probability of getting any one is 1/2. Next, in example 1.2, what is given? A die is thrown. The possible outcomes are 1, 2, 3, 4, 5, 6. So denominator we are writing 6. The probability of getting 4. Getting 4 is getting only once. So we will write 1/6. This is about example 1.2. Next, come to example 1.3. In example 1.3, what is given? Total number of marbles is 5. Total number of, already all these are introduction known topics only, probability related one. Total number of marbles, how many? 5. The probability of picking blue color marble. How many blue color marbles we have? 4. 4 by picking of blue color marble is, so the number of ways we can pick 4 marbles is 4/5. This is one of the example. Next we will see here. Next we will see basic rules of probability. In the probability, we can perform addition, we can perform product, and we can also go for conditional probability. So three ways we can mention the probability. Either we can make two events summation. Sum is called sum of the probability. Two events product is called multiplication of the probability. Next, if this one occurs, the next one is also occurred. That is called as conditional probability. So here, if it is summation rule, each event is excludes the possibility of another event. That is called sum of the rules. Multiplication means here the two rules effect does not affect one another. If event does not affect the probability of occur, and mutually, this is mutual exclusive events. What is the meaning of mutual exclusive here? Summation is mutually, this is one is not affecting the another one, is called as product. We will see in the examples. Next, another one is the conditional probability. Now we will see the example 1.4. Here what is the question is given? A pack of 52 cards. In that 52 cards, we have to take either red ace or black king. Red ace or black king. So total cards is 52. Red ace. How many red ace cards we have? 2 red aces out of 52. So the probability of occurred is 2/52. 2 red ace cards from total number of cards is 2/52. Same way, 2 black kings. Same way, 2 black kings out of 52 cards. 2/52. So here this is mutually exclusive. Both the events are mutually not depending on one another. These two are mutually exclusive events. If it is mutually exclusive events, we can write as summation, sum of the probability. So the first, what is the first one probability? The first one probability is 2/52 plus second probability is also 2/52. So total is 4/52. This 4/52 we are writing as 1/26. 1/26. So this is 1/13. Sorry, 4 by correct na? 2/52, 2/22 is called 1/4 ones are 1/13. So answer is 1/13. So this example is for what? Sum of the probabilities. Next we will see product of two probabilities. Product rule, multiplication rule. What is the multiplication rule? What is the question is given? A bag consists of 6 black marbles, 4 blue marbles. So total number of marbles is 10. 4 black and 6 black, 4 blue. Total marbles is 10. 2 marbles are drawing from the bag without replacements. Means if once I taking, again I am not keeping back. In the previous question, what we discussed, if 2 red aces are removed, 2 red aces removed, how many will be the left? 50. But we are placing those in the bag. So in the example 1.4, after taking the 2 cards, again replacing in the bag, same it is keeping in the bag. So again it is total 52. But here, what is the question? Without replacement. First question is with replacement. Second question is without replacement. So first, how many is picking? What is the question? Blue marbles are picked. Blue marbles. How many blue marbles we have? 4. 4 by 10. So the first P1 equal to 4 by 10. Next, what is given? If once 10 is removed without replacement, so if 1 is removed from 4, we will get 9. Only 1 is removed. We will get 9. So here another marble also picking. Another first blue marble is picked. Another blue marble is also picking. So a product of these two is, which here we will keep 4 by 10 into 3 by 9, which equal to, we will get 2 by 15. So multiplication rule without replacement. First here total marbles we have 4. So 4 by 10. It is not replaced back. If it is not replaced back means minus 1 to the numerator and minus 1 to the denominator. We will write it as 3 by 9. So total probability P equal to P1 into P2. 4 by 10 into 3 by 9 we will get. So this is the example 1 point is for multiplication purpose. Example 1.4 is for the summation purpose. Next example 1.6. Example 1.6 is conditional probability formula. Here what is the conditional probability formula we have? Conditional probability equal P of B by A equal to P of A intersection B by P of A. So here probability of P of A intersection B formula. P of A intersection B equal to P of A times into P of B by A. B, probability of B by A. Now here, what is the question given? Conditional probability formula, this one, or we can write P of A equal to P of A intersection B by P of B by A. P of B by A. This is the formula of conditional probability. Using this conditional probability, we will see the question. Discuss the probability of drawing 2 kings from deck of 52 cards. Actually here the first card of chancing picking king is 4. How many kings we have? 4 kings we have. So the first probability we are taking 4 by 52. Here the question is without replacement. Without replacement. So if you want to take another card, means to do the second event, first event has to be occurred. That is called as conditional probability. Conditional probability lo emundi, to perform second event, first event has to be performed. So this 4 by 52 is first event. Next, second event is 3 by 51. This is 3 by 51. This is second event. So we are calculating probability of event A and B. Both events together we are calculating. Probability of P of A intersection B. Probability of P of A intersection B equal to P of A. P of A is here 4 by 52. P of B by A equal to 3 by 51. So this is conditional probability. Multiplication is mutually exclusive events. Mutually exclusive events. Conditional probability means if the second event has to perform, after performing the first one only, the second event is performed. That is conditional probability. After conditional probability, we have another question just with replacement question. With replacement question. If it is with replacement question, here I am picking blue, total 10. Again, second time I am picking. Again, you are replacing or you are keeping that one in back. So again, second time also you will get 4 by 10. So this is with replacement question. Next we will see. So here this is the so what you how the question is will be asked. What is probability? How you will get question in the exam? What is probability? What are the basic rules of probability? If you get, you have to write these examples. One example is for addition, one example is for multiplication, one example is for conditional probability. Next, after rules of probability, now we will see what is distinguishable particles and what is indistinguishable particles. See, whatever classical mechanics related studies is comes under distinguishable particles. Whatever the quantum mechanics, quantum related particles is called as indistinguishable particles. If it is a distinguishable particle, we can identify the particle. If it is indistinguishable particle, we cannot identify, even its position is changing from one partition to another partition. Even the position is changed, it is difficult to identify the particle. Suppose example, we will see difference between the classical and statistics and quantum statistics. That here is the particles which are related to classical. The particles here, this is important point. The particles which are related to classical statistics, we will call it as distinguishable particles. The particles which are related to quantum statistics are the particles which are indistinguishable, we will call it as quantum statistics. Next, we will see the example. Here, suppose we are taking a partition consist of helium-3 and helium-4. Helium-3 and helium-4 we are concentrating. The two particles are, if it is in helium-3, helium-4. So this is different. So this is comes under distinguishable. Distinguishable particle exam is helium-3 and helium-4. We can able to identify both the particles. This is distinguishable particle. Next we have indistinguishable particle. Here what we are taking example for indistinguishable particle is two protons. Two likely protons are keeping in two partitions. We cannot identify, even the position is switching from one place to another place. So helium-3 and helium-4 is comes under distinguishable, or else we can say as classical statistics is comes under distinguishable. Next, two protons, even it is switching, we are unable to find the changes, physical change we cannot guess, that is comes under indistinguishable particle. Now we will see the same probability example for a distinguishable and indistinguishable. This one is given backside as a, I think, short question from the first unit. What are the distinguishable and indistinguishable particles? Now we will see example 1.8. What is given? Potato. Here P letter is one we have. O letter is given twice. T letter is given twice. A letter is given once. So here potato. Potato means here we will see. So what is there asking? Let us arrange all the letters and compute the probability of obtaining the word starting with P. How starting with P? Total how many letters we have here? 6 letters we have. 6 factorial by here. First we will write total. After writing total, we will see for the P. So first I am writing for the total. Total letters is 6, and we have P 1 letter, 1 factorial. O is 2 factorial. O is 2 letters. Next, T is also 2 letters. 1 factorial, 2 factorial, 2 factorial. Next, A is only 1. That is 1 factorial. This is overall for the potato. Suppose P letter is removed. If P letter is removed means 1 is less. So in the what we have in the numerator, we have 5 factorial by P1, P only 1 factorial I am removing. So what we will get? 2 factorial, 2 factorial, 1 factorial. This is denominator. After removing P, this is before removing P, what we have? 6 factorial by 2 factorial into T factorial. After removing P, we have 5 factorial by 2 factorial into 2 factorial. This calculation part we have After this, we will see what is microscopic and macroscopic parameters. In microscopic parameters is atomic level. The parameters is in the order of atomic. If it is in the atomic level, we will call it as microscopic parameters. Here, this microscopic parameters cannot be measured directly. Here, this measurements is done in the laboratory. The measurements is done in the laboratory. Here, what are the example of microscopic parameters? Small single individual particle is called as microscope. The combination of microscopes is called as macroscope. Two terms we have: micro, macro. Single atomic level, single particle is called as micro. A group or a combination of particles is called as macro. So, what is the examples of microscopic parameters? The macroscopic parameter examples is mass, velocity, energy, momentum, magnetic momentum, constituent. All these things comes under microscopic parameters. Next, we will see macroscopic parameters. In macroscopic is some of the microscope parameter and sigma of micro. Sigma of micro is called as macro. Sigma of macro equal to sigma of micro is called as macro parameters. Next one thing, another topic we will see in this, what is Stirling approximation formula? In Stirling approximation formula, suppose I am taking for n number of values. N number of values is represented with, here I want to take n factorial. How we will write n factorial? N factorial equal to n into n minus 1, n minus 2, n minus 3, so on up to 1. N factorial, how we will write n minus 1, n minus 2, n minus 3, so on up to 4, 3, 2, 1. Up to 1 we will write. To this one, taking log on both sides. After taking log on both sides, what we will get? Log n factorial equal to first term. This first term, n is written as log n. This n, first n is written as log n. N minus 1 is written as log n minus 1. N minus 2 is written as log n minus 2 up to log 1 we are writing. Here log 1 value equal to 0. After writing log 1 value equal to 0, we can write the expression as log n factorial equal to sigma x equal to 1 to n log x. Sigma x is equal to 2 to log x. To this one, I am plotting a graph. What we are taking in this graph? Here I am taking graph as x values, x1, 2, 3, 4, 5, 6, 7. So my x-axis is x, y-axis I am taking as log x. What we have in log x? Log 1, log 2, log 3, log 4. So here the graph is for log 1, we will get this. For log 2, stepwise increment graph. We will get stepwise increment graph. In this stepwise increment graph, here I am joining the points. Here the first one maximum point, the second one maximum point, third one maximum point. Next we have fourth one maximum point. These points are joined together. These points are joined together and it represents like a curve shape. This is about the graph. Now, so here what is our expression? Our expression is logarithm of n factorial is equal to sigma x is equals to 2 from n, what we have? Log x. To this one, I am making further calculation part, integration I am performing. To this one, I am performing integration. What we will get? Integration of x log x dx. Integration of log x dx can be, here we can consider as using integration formula. What is the integration formula? Here we have, what we have integration formula? Integral of u dv is equals to, we using this formula, u v minus integral of v times of du. Apply this formula. So here I am applying this dx. This dx is considered as dv. This log x is considered as u. Log x is considered as u. So what is our formula? integral of u dot dv. So this expression is represents as integral of u dot dv. To this one, apply the formula. So what is our formula? U. Here u means log x is taken as it is. dv. dv means here differentiation of dx is x. Here is this is differentiation term. Differentiation of dx is x. uv term is written. Minus second term v times of du. Here what is v? dx we have. dx we have. dv that one in the, I am writing as x. v term ikkada x avutundi. Differentiation of log x వస్తుంది 1 by x. So the final expression we are getting x times of log x minus 1 by x times of x dx. This x is cancelled. So we are getting the term as x times of logarithm of x from 1 to n minus here we are getting integral of dx. Integral of dx we are getting. To this one, apply the conditions. What we will get? N times of log n. After applying limits, n times of log n minus n times of log n minus 1 log 1 minus 1 times of log 1. This term is for this one. This term is for this one. What we are getting? N log n minus log 1. As log 1 equal to 0. So the first term what we are getting for this one? X log x ki. X log x ki. This x log x ki manaki em vastundi? Ikkada answer for x log x I am getting n terms of log n. N times of log n. Next ikkada manaku 1 undi. This 1 I am taking as a x which the limits is from 1 to n. అప్పుడు మనకి ఏమొస్తుంది? మైనస్ ఆఫ్ n minus 1 వస్తుంది. So what we will write? n log n minus n plus 1. As n is greater than 1, we will get the Stirling approximation as n log n times of minus n. So n log n times of minus n we will get. Just we will recall once again. Here I took log of n factorial. Log of n factorial equal to integral of 1 to n log x dx. Next, this log x dx I applied uv integral of uv formula. So what we got after applying n log n minus n. So this n log n minus n is the Stirling approximation formula. So this is the formula of Stirling approximation. Next we will see the next topic. What we have next topic? Next topic is the most probable distribution. What is the most probable distribution here? The most probable distribution in this here I am concentrating on the total let p be the probability. What we have to write? Let p be the probability. I am concentrating on total probability p distribution for different point cells. Actually, what is point cell? This is a whole space. In this whole space, I am dividing it as a number of cells. In this number of cells, this is single cell. One single cell is called as a point cell. 1. This is another single cell called point 2. This is another single cell called as point 3. This is another single cell called as point 4. Point cell. So phase space point and term. Phase space point means a single cell. This single cell volume is H naught. We will discuss this one in the further. Here we will see the probability equation. What is the probability we have? The probability P equal to capital N factorial by N1, N2, N2, so on, Nk factorial. And in the numerator, we have G1 to the power of Nk, G2 to the power of N2, Gk to the power of Nk. So this is the formula of total probability. This is the formula of total probability. Next, whereas G1, G2, Gn is called as degeneracy. Using this one, now we will take logarithm on both sides, and by applying Stirling equation, we will simplify this one further. Here, setting approximation is completed. Here, we will see the sentences, some sentences, how it is written directly. What is the P here? P equal to capital N factorial by N1 factorial, N2 factorial, N3 factorial up to Nk factorial. And here we have G1 to the power of N1, G2 to the power of N2, G3 to the power of N3, Gk to the power of Nk. Where what is G here? G is the degeneracy factor. To this one, I am taking log on both sides. After taking log on both sides, what we will get? Log P equal to numerator log n factorial from the numerator taking log to the first equation. What is the first equation we have? First equation is P equal to n factorial by n1, n2, n3. What is P? P equal to 2. Here what we have? Here what we have? P equal to, already equation is written, P equal to n factorial by n1 factorial, n2 factorial, nk factorial. P equal to n factorial by first equation రాసాము applying log. After applying log to both LHS and RHS, log P equal to numerator n factorial ki log n factorial minus denominator term n1 factorial, n2 factorial, so on nk factorial we have. This one is also applied log of ni factorial plus the third term, this term G1 whole to the power of n1, G2 whole to the power of n2, G3 whole to the power of n3. This one I am writing as ni times of log Gi. Now here I am applying Stirling approximation. What is the formula of Stirling approximation? Here we are seeing the formula of Stirling approximation is log n factorial is equals to and here the Stirling approximation formula is log n factorial equal to log n factorial equal to n log n minus n. Now here I am applying Stirling approximation to this one. So here log P keeping as it is to log n factorial, I am writing as n log n minus n. Using Stirling approximation, this log n factorial is written as n log n minus n. Next, similarly, log n factorial is written as n log n minus n9. So this is second term. This is second term. This one is first term, and keeping third term as it is. What is third term? Ni times of log Gi. Now we will simplify this one further. So how we will get steps? N log n is written as it is. first one minus n. Sigma is multiplying to the both the terms, first term as well as second term. To the first term multiplication is sigma times of ni log ni. Next to this minus of minus, we will get plus times of sigma of ni. This sigma of ni is choosing as a capital N. So this capital N, this N will be cancelled. So we will get three terms. What are the three terms we are getting? Log P equal to n log n minus sigma of I ni log ni plus sigma ni log gi. To this one, I am performing differentiation. I am taking here. Here the probability is taking as a most probable distribution. The most probable distribution is written as dou by dou n of P maximum. The most probable distribution is written as dou by dou n of P maximum. So from this equation 1, I am writing two terms. Which term is neglected here? I am cancelling this term. Cancelled this term. This term is cancelled and rewriting the equation again, and that is as a equation 2. So equation 2 is first term is cancelled and write next two terms as it is. So after writing next two terms as it is, I am making the first term as a differentiation. Now here I am making differentiation to this equation. Once I will do differentiation to ni, second term I will do differentiation to log ni. So how we will do differentiation? Ni term is written as it is and differentiation of log ni, and second term is log ni is written as it is, ni is written as d of ni. So these two terms is coming from first term, differentiation of ni log n. Ni is written as it is, differentiation of log n. Next, log ni is written as it is, for ni differentiation is d of ni. Next, third term is taken as ni log gi. We are doing differentiation with respect to n. So log gi terms of dni. So this is third term. Here, next we will do here ni as it is, differentiation of log ni, we will get 1 by ni of d of ni. This ni is written as it is. This d of log ni is written as 1 by n times of d of n. So again this ni is cancelled. So from sigma ni log dni which manaki em term vastundi, ni terms of d of log ni, we are getting sigma of dni. And next from second term, what we are getting? Second term, d of ni miss అయింది. So what is second term? Sigma of log ni d of ni, ఇక్కడ d of ni term ఉండాలి, plus third term is written as it is. Afterwards, what we are doing? This sigma of d of ni term, whatever sigma of d of ni is there, this one I am rewriting as sigma of alpha times of d of ni. The first term sigma of d of ni is writing as sigma of alpha times of d of ni, and that one I am substituting. That term I am substituting. So in place of sigma of d of ni, I am writing as sigma of alpha times of d of ni, and remaining two terms is as it is. And take dni in three terms. We have dni. Make sigma of dni is common. So we will get alpha minus logarithm of ni plus logarithm of gi. So make it equal to 0, and we will get one final equation. What is the final equation? We will get ni equal to n times of gi. How we are getting this one? We will see here. Removing the log, we will get ni equal to e power alpha times of gi. So e power alpha times of gi. Here I am replacing e power alpha as capital N. Replace e power alpha. What is e power alpha? Replace e power alpha with capital N. After replacing e power alpha with capital N, what we will get? Small ni is equal to capital N times of gi. Capital N terms of gi. So this is the most probable value. We will cross check this one in the here. The same thing whatever we discussed is there. First formula, apply logarithm. After that, apply Stirling formula. After applying Stirling formula, the first term is only sigma dni. What is this first term? The first term is sigma of dni. Again multiply with alpha. After multiplying with alpha, what we will get? Alpha times of dni. Alpha times of dni. So total 3 terms vastundi. First term is become alpha times of dni, and next terms is written as it is. Next terms is written as it is. So making common in place of E of alpha. E of alpha on the other, in place of E of alpha, substitute capital N. After substituting capital N, we will get Ni equal to N times of Gi. Here, what is small Ni? What is capital Ni? What is Gi? Gi is called as prior probability. Here, Gi is called as prior probability. Here G of I is called as prior probability. Capital N is called as number of balls, and small n is called to how much number of total distribution. Total number of distribution is represented with small ni. Total number of distribution, small ni, is directly proportional to number of balls. Total number of distribution is also directly proportional to Gi. Here DGI is called as degeneracy. Also we can call it as prior probability of Gi. So unit 1 is completed. In unit 1, what we discussed? What we discussed in unit 1? First, in unit 1, from your textbook, first we saw what is probability definition, basic rules of probability. In basic rules of probability, we discussed summation of two probabilities, multiplication of two probability, and conditional probability. After that, we discussed distinguishable and indistinguishable particles. Distinguishable particles is used for classical statistics. Indistinguishable particles is used for quantum statistics. Next, helium-2, helium-3 comes under distinguishable example. Two like protons comes under indistinguishable. Again, if you get this question, you write potato example. Next, we saw what is microscope and macroscope. Microscope is small atomic level is called microscope. We cannot measure this one directly. In the laboratory only we are measuring. Next, what is macroscope? Macroscope is a combination of micros is called macro. Again, we saw the two derivations of Stirling approximation and most probable distribution. Now we will go to unit 2. We have 4 classes online. 4 classes lo 4 blocks nunchi cover chestunam. Iroju block 1 complete chekinta first 2 units. Next class lo block 2 first 2 units alla. 4 blocks cover cheyadaniki try chestam. Next we will see statistical mechanics and thermodynamics. In this statistical mechanics and thermodynamics, what are the things we will study here? We will study about what is different types of first we will see what is microscopic and macroscopic. After discussing microscopic and macroscopic, we will go for the phase space. The whole system is called as phase space. In that, the single cell is called as phase space unit. Again, we will see the different examples. Next, we will see constraints here. Constraints means restrictions. What is constraint? What are the different types of constraints we have? Next, we will see about law of equipartition of energy and relation between the thermodynamic and statistical quantities we will see in this. First, we will come to introduction. What is given in the introduction? The statistical mechanics and thermodynamics both are interrelated with each other. Both are correlated. What are the two things is correlated? Statistical mechanics and thermodynamics both are interlinked with each other. Thermodynamics will tell about macroscopic properties. This thermodynamics is explaining about macroscopic properties. What are the macroscopic properties we have? The macroscopic properties we have is temperature, pressure, energy, and entropy. And whereas we will statistical, what is this statistical is explaining? Statistical is explaining about microscope. So stats cheppedi micro. Statistical is explaining about microscopic properties, and thermodynamics is explaining about macroscopic properties. So what is micro? Macro is the collection of microparticles. Macro is the collection of microparticles. Now we will see here what is microscopic state and macroscopic state. And we will see the example. Here, again, what we discussed previous, the almost same thing will be repeated here. In microstate, we are concentrating on every individual particle within the system. In single particle, I am studying in atomic level. The single particle is studied in atomical level and where it is suitable. This microscopic particles is suitable for mass. We can, what are the parameters we can study? Using this microscopic particles, we can study mass, velocity, energy, momentum, and magnetic momentum. All these things can be studied using microstates. So here enthalpy is also we are studying. Enthalpy is directly proportional to the number of microstates. What is enthalpy? Here enthalpy is represented with S or rho. S or rho తో చూపిస్తామంట. So entropy S is directly proportional to the number of microstates. This is one of the important point here. So entropy is directly related to the number of microstates. And if the entropy is high, number of microstates is high. If entropy is less, number of microstates is less. First paragraph lo em rayali manamu, what is microstate ante it is for individual particle we are studying in the atomic level, and where we are using, what are the parameters we are measuring from this? We are measuring mass, velocity, energy, momentum anedi first paragraph lo rayali. Next, what we have to write in the second paragraph, this microstate is directly associated with the entropy. If the entropy is increasing, microstates also more. If entropy is decreasing, microstates is decreasing. Next we will see. So the first two paragraphs is about micro. The first two paragraphs is about micro. Next we will come to macrostates. So what I said macrostates? Macrostates is the summation of micro. Macrostates is the summation of micro. And here the combination of different microstates is called as macrostates. And here we are seeing the whole system with the average of different microstates. Different microstates యొక్క average ని స్టడీ చేస్తున్నాం. Different microstates యొక్క average ని స్టడీ చేస్తున్నాం. So in this macrostates, what are the examples we can take? In this macrostates, we can concentrate pressure P. Next, came చదవచ్చు మనం volume B. Next, we can study about the temperature and we can study about the S. So pressure studying, volume, temperature, S. These four is belongs to macro. These four is belongs to macro. So in micro lo em చదువుతాం మనం? Micro lo energy, momentum P, and velocity V, and mass. Velocity V and mass. So these are the things we can study in microstate. Next, now we will see the example. So మీకు బ్యాక్ సైడ్ లో ఇది ఎస్ఏ క్వశ్చన్ ఇచ్చారు చూడండి అమ్మా. ఎక్కడ ఇచ్చారు ఇది ఎస్ఏ క్వశ్చన్? మనకి అన్ని బ్లాక్స్ లో బ్లాక్ 1 ఎక్కువ ఈజీగా ఉంటుంది. ఎస్ఏ క్వశ్చన్ ఏమి ఇచ్చారు చూడండి, 165 పేజీలో ఎక్స్ప్లెయిన్ ఇన్ డీటెయిల్ అబౌట్ మైక్రోస్కోప్ అండ్ మైక్రోస్టేట్స్. అంటే మీరు ఎక్కడి నుంచి రాయాలి ఇది ఎగ్జామ్ లో? ఇది ఎగ్జామ్ లో మనకు 2.3 క్వశ్చన్ విత్ ఎగ్జాంపుల్స్ రాయాలి. 2 టేబుల్స్ రాసి ఎగ్జాంపుల్ కూడా మనమే తీసుకోవాలి. ఎగ్జాంపుల్ తీసుకొని 2 టేబుల్స్ ఎక్స్ప్లెయిన్ చేయాలి. డెఫినేషన్స్ రాసాక ఇక్కడ చూడండి, మనం ఇప్పుడు ఏం తీసుకున్నాం? హీలియం గ్యాస్ తీసుకున్నాము. హీలియం గ్యాస్ విత్ ప్రెషర్, సమ్ ప్రెషర్ P = 1 అండ్ టెంపరేచర్ 290. మనకి ఇదంతా ఎగ్జాంపుల్ మ్యాటర్ రాదు. సో నౌ హియర్ ఐఎమ్ క్యాలిక్యులేటింగ్ మైక్రోస్టేట్స్ అండ్ మ్యాక్రోస్టేట్స్. టోటల్ నంబర్ ఆఫ్ స్టేట్స్ ఏమో మైక్రో అంటాము. న్యూమరేటర్ లో డినామినేటర్ లో కూడా మైక్రోనే వస్తుంది, కానీ నంబర్ ఆఫ్ మైక్రో బై టోటల్ నంబర్ ఆఫ్ మైక్రో గల వస్తాం అనమాట. నంబర్ ఆఫ్ మైక్రో బై న్యూమరేటర్ లో మైక్రో, లైక్ ప్రాబబిలిటీ ఫార్ములా ఉంది కదా, నంబర్ ఆఫ్ ప్రాబబిలిటీస్ బై టోటల్ నంబర్ ఆఫ్ ప్రాబబిలిటీస్. అంతే ఫార్ములా, సేమ్ ప్రాబబిలిటీ ఫార్ములా అప్లై చేసిన. నంబర్ ఆఫ్ స్టేట్స్ బై టోటల్ నంబర్ ఆఫ్ స్టేట్స్. నంబర్ ఆఫ్ స్టేట్స్ బై total number of states we will take. So example ఏమి ఇచ్చారు చూద్దాం. ఎగ్జాంపుల్ ఏమి ఇచ్చారు? 3 coins. So different ways, 3 coins tossing 3 coins. Tossing 3 coins in different ways. Tossing 3 coins in different ways. What are the possible? Head. All heads ఒక combination. 2 heads వచ్చేది ఒక combination. 2 tails వచ్చేది ఒక కాంబినేషన్. ఆల్ టైల్స్ వచ్చేది ఒక కాంబినేషన్. సో డిఫరెంట్ కాంబినేషన్స్ మనకి ఎన్ని వస్తున్నాయి ఇక్కడ? ఆల్ హెడ్స్ అని వస్తుంది, 2 హెడ్స్ అని వస్తుంది, 2 టైల్స్ అని వస్తుంది, ఆల్ tails వస్తున్నాయి. సో ఇది all heads వచ్చేది 1 possibility, 2 heads వచ్చేది 3 possibilities, 2 tails వచ్చేది 3 possibilities, all tails వచ్చేది 1 possibility. సో total number of occurs ఎన్ని వస్తుంది? 3 plus 3 6 7 8. సో డినామినేటర్ ఏం రాస్తాము? 8 రాస్తాం. బేస్డ్ ఆన్ ద క్వశ్చన్ న్యూమరేటర్ చేంజ్ అవుతుంది. మై న్యూమరేటర్ క్వశ్చన్ ఇస్ ఫర్ ఆల్ హెడ్స్ అని అడిగారు అనుకోండి, ఆల్ హెడ్స్ కి ఎంత ఉంది పాసిబిలిటీ? 1 ఉంది, 1/8. దిస్ ఇస్ ఫర్ ఆల్ హెడ్స్. నెక్స్ట్ ఆల్ టైల్స్ అడిగారు అనుకోండి, ఆల్ టైల్స్ పాసిబిలిటీ ఎంత ఉంది? 1 ఉంది, 1/8. 2 హెడ్స్ కాంబినేషన్ అడిగారు, 2 హెడ్స్ కాంబినేషన్ ఎన్ని వస్తున్నాయి? 3, 3/8. 2 tails combination is asking. If 2 tails combination is asking, you have to write 3/8. So 3 tossing coin the example. Actual number, how many states we have? Any states? 1 2 3 4 states. So 4/8. First వచ్చేది 4/8. All possible outcomes is 4/8 ఒకటి ఆన్సర్ వస్తుంది. మరి డిఫరెంట్ ఆప్షన్స్ కి ఐదర్ 1/8 వస్తుంది, 3/8 వస్తుంది, 3/8 వస్తుంది, 1/8 వస్తుంది. This is one example. Next we will take another example. Here we have 4 particles A, B, C, D. How many particles we have? 4 particles A, B, C, D. ఈ 4 particles ని 2 cells లో పెట్టాలి. ఈ 4 particles ని 2 cells లో పెట్టాలి. So what are the possible ways we have? Permutations. ఎన్ని possibilities ఉన్నాయో రాయాలి. ఫస్ట్ ఏంటి? ఫస్ట్ సెల్ లోనే మనకి ఏ వచ్చేసింది, బి వచ్చేసింది, సి వచ్చేసింది, డి వచ్చేసింది. అప్పుడు సెకండ్ సెల్ ఇస్ 0. నెక్స్ట్ కాంబినేషన్ ఒక దాంట్లో 1 పెట్టచ్చు, ఒక దాంట్లో 3 పెట్టచ్చు. నెక్స్ట్ కేసు ఒక దాంట్లో 3 పెట్టచ్చు, ఇంకో దాంట్లో 1 పెట్టచ్చు. నెక్స్ట్ పాసిబిలిటీ బోత్ ఈక్వల్లీ డిస్ట్రిబ్యూటింగ్ 2 2. ఎన్ని ఆప్షన్స్ పాసిబుల్ ఉంటాయి? నంబర్ ఆఫ్ స్టేట్స్ ఇక్కడ రాయాలి. సపోజ్ ఏబిసిడి 4 ఒకటే దాంట్లో పెడితే ఇది 0 అయిపోయింది, 1. నెక్స్ట్ ఇక్కడ ఏ పెడితే ఇక్కడ బిసిడి, ఇక్కడ బి పెడితే ఏసిడి, సి పెడితే ఏబిడి, డి పెడితే ఏబిసి. సో హౌ మెనీ ఆప్షన్స్ వీ హ్యావ్ హియర్? 4. నెక్స్ట్ 3 1 కాంబినేషన్స్ ఎన్ని ఉన్నాయి? 4 ఉన్నాయి. నెక్స్ట్ 2 2 కాంబినేషన్స్ ఎన్ని ఉన్నాయి? 4 ఉన్నాయి. నెక్స్ట్ 0,4 స్టేట్స్ ఎన్ని ఉన్నాయి? 1 ఉంది. సో ఎన్ని పాసిబుల్ స్టేట్స్, ఎన్ని కాంబినేషన్స్ మనకు పాసిబుల్? ఇక్కడ 1 కాంబినేషన్, దిస్ ఇస్ సెకండ్ కాంబినేషన్ ఇస్ పాసిబుల్, this is third combination is possible, this is fourth combination is possible. In the 5 combinations is possible. So what is numerator? 5 combinations is possible. So 5 by ఇవన్నీ అడిషన్ చేసేసాను. ఎన్ని ఉన్నాయి? 1 + 4 5, ఇది 10 15 16, డినామినేటర్ లో 16, 5/16 బేస్డ్ ఆన్ ద టేబుల్. చూడండి ఇక్కడ. సో ఫస్ట్ కాంబినేషన్ మనకి ఏమొచ్చింది? ఓవరాల్ combinations we got 5/16. Next options, 4 0 combinations, how many we got? 4 0 combination we got only 1, so 1/16. 1, 3 combinations, how many we got? 4, 4/16. Next 3, 1 combination, how many we got? We got 4, 4/16. Next 2/2 combinations, how many we have? We have 6/16. Next 0,4 combination we have 1, so 1/16. Like this is about 2 examples, right? So if you get this topic, you have to write the definition of what is microstates with examples. What is macrostate with examples. Next 2 tables explain cheyali. This is a question ke raavachu, back side undi. Next topic we will see what is phase space. Next we will see what is phase space. In general, in statistical mechanics, we will study about 3-dimensional, 3 coordinates. 3 coordinates means x-axis, y-axis, z-axis. 3-dimensional, we will take 3 coordinates. This one, we will write a volume dV as dx, dy, dz. This dx, dy, dz is called as position coordinates. Position coordinates is represented with q. Q1, Q2, Q3. So, two types of coordinates we have: position coordinates and momentum coordinates. This position coordinates is represented with Q1, Q2, Q3. Momentum coordinates is represented with P1, P2, P3. This position coordinates is along x-axis లో గనుక Q1, Q2, Q3 రాస్తాము. Along ఇక్కడ మనకు momentum coordinates also along XYZ axis కనుక PX అని రాయొచ్చు. PX, PY, PZ. ఇక్కడ కూడా Q దగ్గర QX, QY, QZ. Position and momentum coordinates. I am taking the whole volume. Volume is a combination of position and momentum. Volume is a combination of position and momentum. This position coordinates, what we have? My position coordinates Q1, Q2, Q3 రాయొచ్చు, or we have position coordinates is represented with dx, dy, dz. These are position coordinates. What is momentum coordinates? We have momentum coordinates is writing P1, P2, P3, or in terms of different D's, we can write dpx, d of py, I can write d of pz. So these are called momentum coordinates. This is called position coordinates. So suppose the entire space is called as phase space. If I am taking a single partition of the phase space, this single partition is called as phase space point. Which point we will call? Phase space point. The whole space is called as phase space. The whole space is called as phase space. This phase space is represented with position and momentum coordinates. In this, the single side is called as phase space point. Phase space point. This phase space point having some small volume H0. Phase space will take small volume H0. This H0, I am writing this H0, I am writing for x coordinate. Also, this H0 I am writing for y coordinate. Again, this H0 is also writing for z coordinate. So, how many coordinates to this H0 small element I am writing? This small element I am writing for x, y, z. So, total I am taking as H0 cube. For XYZ coordinates, I am taking as H0 cube. Now we will see in this what is explaining in these paragraphs. The first space, what is given? The position is represented with XYZ. With its elements is written as dx, dy, dz. Same way, momentum is represented with px, py, pz. And it is expressed as dvp equal dpx, dpy, dpz. And product of 2, total volume is equal to product of 2. And a small subdivided into small cell and taking a small volume as H0. H is the uncertainty principle. Overall is written. Now, this one we will write for here total how many position coordinates we have? Position coordinates we have XYZ or QX, QY, QZ. So this QX, QY, QZ is represented in 3-dimensional. Same way, momentum PX, PY, PZ. This one is also represented in 3-dimensional. So total it is 6-dimensional space. 3n coordinates is for position, 3n coordinates is for momentum. So total is 6-dimensional phase space. In this 6-dimensional phase space, we will write this as 3n is for position, 3n is for momentum. So total it is 6-dimensional space. This 6-dimensional space is represented as a gamma space. 6-dimensional space is written as gamma space. This gamma space is written as T like this. This is gamma space. Next, in this what we see, we can see just now we also saw this diagram. This x-axis is position coordinate, y-axis is momentum coordinate. In this, I am dividing into small subcells, each cell having volume H0. This H0 is for x. This H0 is taken as y coordinate. This small H0 is taken as Z coordinate. So total H naught whole Q. So two-dimensional energy diagram. Suppose we are taking this one as a drawing as a path in the phase space. How it is path, how the particle's path is showing in the phase space is not linear like this. It is not linear. Joining these points. So we are not getting linear paths. Trajectory path we are getting. So joining the path, whatever we got, it is not in linear. Not a linear path is a random trajectory path in the phase space. Now next we will see example 2.4. What we have in example 2.4 here, harmonic oscillator is taken with energy formula. What is the energy formula of the harmonic oscillator? We have E equal to P square by 2m plus of K square. Example 2.4. In that we will see what is the trajectory path we have. E equal to P square by 2m plus KQ square by 21. And this is writing as P square by 2me plus KQ square by 2e. Just E is brought to the denominator. Next, I am writing this one in as a square by B square plus ఒక ఫార్ములా ఉంటుంది కదా మ్యాథ్స్ లో a square by x square plus b square by y square equal ellipse ఫార్ములా ఐ థింక్ ఈ ఫార్మాట్ లో రాస్తున్నాను p square by 2me plus kq ఇక్కడ k లేదు ఇక్కడ p square by 2me plus q square by 2e by k equal to 1. సో మీకు టెక్స్ట్ బుక్ లో m క్యాన్సిల్ చేయండి అమ్మా. ఇక్కడ మీకు టెక్స్ట్ బుక్ లో ఈ టర్మ్ ప్లేస్ లో మనకు టెక్స్ట్ బుక్ లో ఏమి ఇచ్చారు 2me by k ఇచ్చారు. అక్కడ m ఉండదు, ఇక్కడ m ఉండదు, m క్యాన్సిల్ చేసుకోండి టెక్స్ట్ బుక్ లో. సో మనకి ఇక్కడ వచ్చేది 2e by k. సో x square value 2me, y square value is 2e by k. So in terms of x coordinate and y coordinate we are writing one parameter is under root of 2me, another parameter is under root of 2e by k. Another parameter is under root of 2e by k. Next example we will see quantization of phase space. What we have quantization of phase space. Next, after example 2. So just here we don't have m. M undadu indulo. Next we will see quantization of phase space. As we discussed, phase space with xyz coordinates and the total volume is position coordinates as well as momentum coordinates. Here dx, dy, dz is position coordinates. dpx, dpy, dpz is momentum coordinates. The total volume we equal dx1 to dxn, dp1 to dpn. So here I am concentrating for the single position is x or q అనుకోవచ్చు. ఇక్కడ xyz or q అనుకోవచ్చు. పొజిషన్ ని momentum ని p అనుకోవచ్చు. సో q into p is equals to Planck's constant h. Here uncertainty principle అని మనకు ఒకటి ఉంటుంది, ఆ ఫార్ములా త్రూ రాసిరన్నమాట. సో delta of p of x into delta of x equal to h అన్నమాట. So here for the n-dimensional space, microstates for n-dimensional, here this is the shape sigma 9, sigma కాదు omega అనుకుంటా, omega equal to total volume by the volume of single cell. Total volume, what we are calling total volume is V, and volume of the single cell is taken as H of F. Now we will see the example formula for this one. What is given for the example here? Example 2.5. Example 2.5, what is given? E equal to p square by 2m, where the value of p, or we can write p equal to plus or minus under root of 2me. Using this one, I am calculating volume. What is the volume we have? Volume equal to position coordinates and momentum coordinates. Here position coordinate is represented as x and momentum coordinate is represented as p. So integral of dx, integral of dp. Here position coordinate I am writing in place of integral of dx, I am writing L. Integral of dp I am writing as 2 times of position. Why I am taking 2 means here I am taking in both, magnitude is taken in both the directions. So as we are taking in both the direction, the factor 2 is included, L times of 2p. This is what volume formula. So after writing volume formula, so we have number of microstates. What is the formula of number of microstates equal to 2p into L by H. So మనకి ఇక్కడ P already is given. What is P is given? P equal to under root of 2me. పైన రాసాం కదా, P equal to under root of 2me is substituted. So 2L times of this 2L times of under root of 2me by H. So what we will get 2 root 2. Then differentiate this one. Differentiate with respect to energy term. Differentiate చేస్తే d rho equal to ఇక్కడ కాన్స్టెంట్ కదా ఇది 2L by H is constant. This constant term is kept beside 2L dot H and I am differentiating with respect to E. E term ni differentiate చేస్తున్నాను. So 2m is write separately. For E to the root E కి ఏంటి differentiation? 1/2 e to the power of root E ఏం రాస్తాం మనం? E to the power of 1/2 రాస్తాం. E to the power of 1/2 కి differentiation ఏమొస్తుంది? 1/2 e to the power of minus 1/2 వస్తుంది. So that one is written 1/2 e to the power of minus 1/2. This 2 and this 2 is cancelled. L by H is taken and E will come to the denominator and we will get one equation as under root of 2me by E times of D. So we are taking with respect to E to D. Now we will see this one. ఇక్కడ చూద్దాం. So what we did, 2 written as it is, L is written as it is. In place of P, 2me is substituted. In place of P, 2me is substituted and H is written as it is. So this is printing mistake. What is the answer we got? Is it C here? ఇది డిఈ సి కాదమ్మా, అండర్ రూట్ ఆఫ్ 2m by e times of c కాదు, ఇది కరెక్షన్ చేసుకోండి. L by H under root of 2m by e times of DE. Mistake here. C కాదు, అది DE. So మనకి P value is under root of 2me కదా. So here I said it is taking in 2 ఎందుకు తీసుకుంటున్నాం అనే దానికి రీజన్ ఇది. 2, why we are taking 2 means this 2m under root of 2me we are taking both in positive direction as well as in negative direction. For that we wrote 2 times. For that we wrote 2 times. So this is about what we discussed. Example is then kindamma. This example is about quantization of phase space. Next we will discuss next topic. What is constraints? Constraints means here restrictions. Some set of conditions or restrictions is kept. In general also we can say the term constraints. We have some restrictions to perform something. Same way here in statistical mechanics also we have some constraints or restrictions. If you have restrictions we are unable to do some works. So here we will see what are the different types of constraints we have in both statistical mechanics as well as thermodynamics. This we have some constraints. Constraints means conditions are kept for performing operations. These constraints define the way particle can move. So for moving the particle, whether it will move or whether it is interacting or whether it is exchanging. So for moving, for interacting, for exchanging, to perform these 3 operations. To perform these 3 operations. What are the 3 operations? Either moving, interacting or exchanging of energy. We have some restrictions. So what we will see, what are the different restrictions we have. What are the different restrictions we have? We will see how many types and how it will generate. First one is mechanical constraints. What we have in mechanical constraints? In mechanical constraints, we have fixed boundary conditions, particle attached to the rigid bodies or surfaces. Mechanical constraints in rigid body ante manaki ikkada itla untundi. సో పార్టికల్ కెనాట్ మూవ్, ఇక్కడ నుంచి ఇక్కడికి మూవ్ కాదు, పార్టికల్ ఇక్కడ నుంచి ఇక్కడికి, బికాస్ వీ హ్యావ్ రిజిడ్ సర్ఫేస్ ఇన్ ద మిడిల్. మెకానికల్ కన్స్టెంట్స్ కి వీ హ్యావ్ రిజిడ్ సర్ఫేస్ అండ్ వాట్ ఆర్ ద ఫిక్స్డ్ బౌండరీస్. బౌండరీస్ ఈజ్ ఆల్సో ఫిక్స్డ్, నో చేంజెస్ ఇన్ ద బౌండరీస్. బౌండరీ కూడా మనకు ఫిక్స్ గా ఉంటుంది అండ్ పార్టిషన్ ఉంటుంది అండ్ వాల్యూమ్ కూడా ఫిక్స్ గా ఉంటుంది. దట్ ఈస్ మెకానికల్ కన్స్టెంట్స్. నెక్స్ట్ వాట్ ఈస్ థర్మల్ కన్స్టెంట్స్? నో ఎనర్జీ ఎక్స్చేంజ్. వాట్ ఈస్ ద మీనింగ్ ఆఫ్ నో ఎనర్జీ ఎక్స్చేంజ్? సపోజ్ ఎనర్జీ E1 ఉంది, ఇక్కడ మనకి ఎనర్జీ E2 ఉంది. E1 ఇటు పోలేదు, E2 ఇటు పోలేదు. నో ఎనర్జీ ఆఫ్, నో ఎక్స్చేంజ్ ఆఫ్ ఎనర్జీ. నెక్స్ట్ కెన్ ఎక్స్చేంజ్ ఎనర్జీ. వి హ్యావ్ సో ఇన్ థర్మల్ మనకి ఇది 3 పాయింట్స్ నెక్స్ట్ బాగా రిఫర్ చేస్తాం. వాట్ ఈస్ ఐసోలేటెడ్, వాట్ ఈస్ క్లోజ్డ్, ఓపెన్ అనేది మనకు నెక్స్ట్ వచ్చే టాపిక్స్ లో రిపీటెడ్ గా ఈ వర్డ్స్ యూజ్ చేస్తాం. సో రిమెంబర్, ఇన్ ఐసోలేటెడ్ సిస్టమ్ ఎనర్జీ is not exchanged. In closed system energy is exchanging but matter is not exchanging. Next, in open system both energy and matter can be exchangeable. That is called as thermal constant. In thermal constant no energy exchange. In a closed system energy is exchanged but no matter exchange. In open system both are exchanging. Next we have chemical constants. What is chemical constants? In this fixed number of particles. Particles is represented with n. So n value manamu fix పెట్టాలి. నెక్స్ట్ వేరియబుల్ పార్టికల్ నంబర్. సో ఇఫ్ n ఫిక్స్ పెడితేనేమో దట్ ఈస్ కాల్డ్ as canonical ensemble. నెక్స్ట్ వస్తాయి మనకి ఇవి. ఇఫ్ number of particles we are keeping fixed, it is called as canonical ensemble. If number of particles are changing, we will call it as grand canonical ensemble. We will see these terms in the further. Next we have statistical constraints. In statistical constraints we will take a probability P and we will write as its normalization. Normalization is equal to 1. This is about statistical constraints. Next we have so 4 types of constraints చెప్పాలి. ఫస్ట్ కన్స్ట్రెంట్ క్వశ్చన్ వచ్చింది అనుకోండి, డెఫినేషన్ ఆఫ్ కన్స్ట్రెంట్ రాసేసి there are 4 types of constraints: మెకానికల్, థర్మల్, ఇంకేముంది కెమికల్ కన్స్ట్రెంట్స్ అండ్ స్టాటిస్టికల్ కన్స్ట్రెంట్స్ అని 4 గురించి రాయాలి. నెక్స్ట్ ఈ 4 గురించి రాసినాక మనం ఏం చేయాలి? నెక్స్ట్ డెఫినేషన్స్ రాయాలి. వాట్ ఈస్ ఐసోలేటెడ్ సిస్టమ్, వాట్ ఈస్ క్లోజ్డ్ సిస్టమ్, వాట్ ఈస్ ఓపెన్ సిస్టమ్. మనం పైన చెప్పాం కదా, ఈ 3 ఎందులో వస్తున్నాయి? థర్మల్ కన్స్ట్రెంట్స్. సో ఓన్లీ థర్మల్ కన్స్ట్రెంట్స్ సబ్ హెడ్డింగ్ ని ఎక్స్ప్లెయిన్ చేస్తున్నారు. Only thermal constraints subheadings to explain that. What is thermal constraints? We have 3 subheadings. First one isolated system, second one closed system, third one is open system. In the previous slide em chesam manam isolated system lo no exchange of energy. In closed system lo em avutundi, energy exchange avutundi gaani matter exchange avvadu. Next in open system both are exchanging. So danni elaborate chesi rayali which is fixed, which is constant. So in first one is isolated system. Isolated system is also called as microcanonical ensemble. ఇక్కడ నుంచి మనకి ఇంపార్టెంట్ టర్మ్స్ వస్తాయమ్మా. వాట్ ఈస్ మైక్రోకెనానికల్ ఎన్సెంబుల్ అని ఉంటుంది. మైక్రోకెనానికల్ ఎన్సెంబుల్ లో NVE ఫిక్స్ పెట్టేస్తాం. NVE ఫిక్స్ పెట్టేస్తాం అంటే ఓన్లీ మ్యాటర్ కెన్ చేంజ్. ఇందులో మ్యాటర్ ఒకటే ఎక్స్చేంజ్ అవుతుంది, NVE ఫిక్స్ పెడితే అది మైక్రోకెనానికల్ ఎన్సెంబుల్. నెక్స్ట్ వి హావ్ కెనానికల్ ఎన్సెంబుల్ ఆర్ క్లోజ్డ్ సిస్టమ్. Just now we discussed in closed system energy exchanging but matter is not exchanging. Energy exchange అవుతుంది ఇక్కడ, అంటే ఎనర్జీని ఫిక్స్ పెట్టవద్దు. ఏం ఫిక్స్ పెట్టాలి ఇక్కడ? నంబర్ ఆఫ్ పార్టికల్స్ ఇస్ ఫిక్స్డ్, వాల్యూమ్ ఇస్ ఫిక్స్డ్, టెంపరేచర్ ఫిక్స్. ఇఫ్ NVT is ఫిక్స్ ఉంది అనుకోండి, NVT కాంబినేషన్ ఫిక్స్ ఉంది అనుకోండి, that is called as canonical ensemble. Next grand canonical ensemble. In grand canonical ensemble both energy and matter both are exchangeable. In this, what are the things we are keeping fixed? Chemical potential mu, volume V, temperature T. Mu, V, T, these 3 are in fixed position. Next, what is accessible states? Means మనకు పాసిబిలిటీ ఉంది, యాక్సెస్ చేయొచ్చు అనమాట. సపోజ్ యూ హ్యావ్ 3 పార్టికల్స్ ఉన్నాయి. ఇక్కడ 2 పెట్టుకొని 1 పెట్టుకునే కాంబినేషన్ ఉంది, 1 పెట్టుకొని 2 పెట్టుకునే కాంబినేషన్ ఉంది. అనదర్ కాంబినేషన్ 2 కంపార్ట్మెంట్స్ లో ఫిక్స్ చేయాలంటే 2,1, 1,2. దీస్ ఆర్ యాక్సెసిబుల్ స్టేట్. ఇన్యాక్సెసిబుల్ స్టేట్స్ అంటే 3 పార్టికల్స్ ఉన్నాయి, 2 కంపార్ట్మెంట్స్ లో పెట్టాలి. 3 particles 3 compartments లో పెట్టాలి. సో డోంట్ కీప్ ఎనీ కంపార్ట్మెంట్ ఎంటీ, ఏది ఎంటీ ఉండదు. సపోజ్ నేను కాంబినేషన్ రాస్తున్నాను 3,0 0,3. సో ఇందులో సెకండ్ కంపార్ట్మెంట్ ఈస్ ఎంటీ, ఇన్ దిస్ first compartment is empty. So this combination is not possible. So I am calling this as inaccessible state, this one as accessible state. Next we will see law of equal partition of energy. This law of equipartition energy, and two topics we have: law of equipartition energy and relation between thermodynamics and statistical mechanics. We will see what is law of equipartition energy. Here we are writing energy. Just now previously we will discussed position coordinates. Position coordinates is represented with q1, q2, q3, so on, qf, and momentum coordinates is p1, p2, p3, so on, pf. So this position and momentum coordinates is writing in terms of total energy equation. So energy E equal to capital E times of, this is q1 to qf is position coordinates and p1 to pf is momentum coordinates. Using these coordinates again to this one, I am adding epsilon. One momentum function I am adding, I'm adding extra function. What is that extra function I am adding to the equation? I am adding momentum function. What is momentum function? Momentum function is represented with sigma of p of I. Momentum function is represented with epsilon times of sigma of pi. So again we are rewriting the equation. E equal to sigma times of pi plus the original equation is written as it is. Now we will see this second term consists of both position coordinates as well as momentum coordinates. Both position and momentum coordinates. Now here I am taking as mean energy equation. And here what is mean energy equation? Mean energy equation is epsilon times of here mean energy equation. How I am writing mean energy equation? Epsilon times of exponential term by only exponential term. Epsilon times of exponential term by only exponential term. Again we have position coordinates dq1 to dqk, dp1 to dp1 to dpk. Same way denominator also I am writing dq1 to dqk, dp1 to dpk. I am writing here, I am using numerator as E. Again I am replacing this numerator E. E is replaced with epsilon plus E dash. This E is replaced with epsilon plus E dash. Again I am rewriting the equation. Again rewrite the equation. So after rewriting, epsilon is as it is, exponential of, in place of E I am substituting epsilon plus E dash. In place of E I am substituting epsilon plus E dash. Next what I am making? I am making two separate exponential of first term, exponential of second term. Again we will rewrite the equation. So what is the equation? Epsilon EI is as it is. Epsilon EI is as it is. Exponential of first term is minus epsilon by kt. What is second term? E dash by kt. First term, second term. Same way, this exponential of first term is epsilon by kt. Second term is E by kt. Two terms is written. dq1 to dqf untadamma ikkada. dq1 to dqf వరకు రాయాలి. dp1 to dpf రాయాలి. ఇక్కడ కూడా అంతే. dq1 డాట్స్ పెట్టి ఏం పెట్టాలి? ఇక్కడ డాట్స్ పెట్టి dqk పెట్టేసి పక్కన dp1 to dpf పెట్టాలి. ఇది క్యాన్సిల్ అయిపోతుంది. ఈ న్యూమరేటర్ లో ఈ సెకండ్ టర్మ్ క్యాన్సిల్ అయిపోయింది. సో మనకి ఏం మిగిలింది? ఫస్ట్ టర్మ్. న్యూమరేటర్ లో డినామినేటర్ లో ఓన్లీ ఫస్ట్ టర్మ్స్ మిగిలాయి. వాట్ ఆర్ ద ఫస్ట్ టర్మ్స్ వి హ్యావ్? epsilon I equal to epsilon times of exponential of minus epsilon by kt by minus epsilon by kt. So in place of epsilon I am substituting p square by 2m. epsilon I place లో ఏం సబ్స్టిట్యూట్ చేస్తున్నాను? p square by 2m రాసి మళ్ళీ రిటర్న్ ద ఈక్వేషన్. ఈ ఈక్వేషన్ ని రీరైట్ చేస్తున్నాను. ఇందులో మనకి ఒక ఫార్ములా ఉంది. వాట్ ఆర్ ద ఫార్ములా వి హ్యావ్? న్యూమరేటర్ ఫార్ములా చూద్దాం ఫస్ట్. ఫస్ట్ న్యూమరేటర్ ఫార్ములా రాద్దాం, తర్వాత గాసియన్ ఫార్ములాస్ అని మనకు 2 ఫార్ములాస్ ఉన్నాయి. న్యూమరేటర్ కి ఒక ఫార్ములా, డినామినేటర్ కి ఒక ఫార్ములా, డైరెక్ట్ ఫార్ములా సబ్స్టిట్యూషన్ అది. వాట్ ఆర్ ద ఫస్ట్ ఫార్ములా వి హ్యావ్? ఆల్రెడీ ఇక్కడ ఇచ్చారు కదా, ఆల్రెడీ ఇక్కడ ఉంది ఫార్ములా. సో వాట్ ఈస్ ద ఫార్ములా? ఇంటిగ్రల్ ఆఫ్ ఎక్స్ స్క్వేర్ ఈ పవర్ మైనస్ ఏఎక్స్ స్క్వేర్ ఈక్వల్ టు 1/2 అండర్ రూట్ ఆఫ్ పి బై ఏ క్యూబ్. ఇప్పుడు ఇదేంటిది? పిఐ స్క్వేర్ ని నేను ఎక్స్ స్క్వేర్ రాస్తున్నా. పిఐ స్క్వేర్ ఏం రాస్తున్నా? ఎక్స్ స్క్వేర్ ఎక్స్పోనెన్షియల్ ఆఫ్ ఎక్స్ స్క్వేర్ మైనస్ 1/2 పై ఎంకేటి. మైనస్ కాదు, ఎందుకంటే ఫార్ములాలో మైనస్ ఏ స్క్వేర్ ఉంది కనుక. సో 1/2 పై ఎంకేటి టర్మ్ ని నేను ఏ రాసుకుంటున్నాను, 1/2 ఎంకేటి. ఇక్కడ ఎం రాదు, 1 మినిట్. ఎం ఉందా? టీ స్క్వేర్ బై 2m. ఓకే, 1/2 ఎంకేటి టర్మ్ ని నేను ఏ అనుకుంటున్నాను. సో ఇక్కడ ఈ ఈక్వేషన్ తో కంపేర్ చేద్దాము. ఎక్స్ స్క్వేర్ ప్లస్ లో పీ స్క్వేర్ పెట్టాను. ఎక్స్ స్క్వేర్ ఎక్స్పోనెన్షియల్ ఆఫ్ మైనస్ ఏ ఎక్స్ స్క్వేర్ డిఎక్స్. సో న్యూమరేటర్ లో ఈ ఫార్ములాలో సబ్స్టిట్యూట్ చేయాలి. డినామినేటర్ ఇస్ ఇన్ ద ఫార్మ్ ఆఫ్ రూట్ పై ఏ. సో ఇప్పుడు ఇక్కడ 1/2m అనేది కాన్స్టెంట్, మనకు సపరేట్ టర్మ్ ఉంది. ఈ 1/2m ని బయట రాస్తున్నా. 1/2m టర్మ్స్ ఆఫ్, ఫస్ట్ న్యూమరేటర్ మనకి ఏమొచ్చింది? 1/2 టర్మ్స్ ఆఫ్ అండర్ రూట్ ఆఫ్ పై బై ఏ క్యూబ్. ఇది న్యూమరేటర్ టర్మ్. డినామినేటర్ టర్మ్ లో ఏం రాయాలి? అండర్ రూట్ ఆఫ్ పై బై ఏ రాయాలి. సో ఇక్కడ మనకి ఇంట్లో రూట్ పై ఉంది, ఇలా రూట్ పై పోతుంది. ఇది రూట్ 1/a ఉంది, ఇంకా ఒక ఏ పోతే, కానీ ఇక్కడ ఏ స్క్వేర్ మిగులుతుంది. ఈ స్క్వేర్ రూట్ పోతే ఓన్లీ ఏనే అవుతుంది. సో ఇక్కడ ఏముంటుంది మనకి? 1/4m టైమ్స్ ఆఫ్ 1/a వచ్చింది. 1/4m టైమ్స్ ఆఫ్ 1/a వచ్చింది. నౌ ఏ వాల్యూ సబ్స్టిట్యూట్ చేయండి. 1/4m టైమ్స్ ఆఫ్ వాట్ ఈస్ ఏ? ఇక్కడ ఏ 1/2mkt కదా. ఏ ఈక్వల్ టు 2mkt. ఇక్కడ ఏ ఈక్వల్ టు మనం 2m టైమ్స్ ఆఫ్ kt తీసుకున్నాం, అది ఇక్కడ సబ్స్టిట్యూట్ చేద్దాం. 1/4m టైమ్స్ ఆఫ్ 1/2m. 1/a అంటే రెసిప్రోకల్ అవుతుంది. ఇది రాంగ్, ఇది రెసిప్రోకల్ అవుతుంది. ఇక్కడ రాస్తాం. ఇక్కడ ఏమవుతుంది? ఇది 1/4m. ఏ ఈక్వల్ టు 1/2mkt అయితే 1/a ది న్యూమరేటర్ లోకి వెళ్తుంది, 2mkt. సో 4m 2m 2 పోతే 1/2 వచ్చింది. సో మనకు ఆన్సర్ ఏమొచ్చింది? 1/2 టైమ్స్ ఆఫ్ kt. 1/2 టైమ్స్ ఆఫ్ kt. సో వాట్ వి గాట్? epsilon I equal to we got 1/2 of the kt. సొల్యూషన్ కింద చూద్దాం. సో మనం ఇక్కడ 2 ఫార్ములా సబ్స్టిట్యూట్ చేయాలి. మైనస్ ఇన్ఫినిటీ టు ప్లస్ ఇన్ఫినిటీ ఈ పవర్ మైనస్ ఏఎక్స్ స్క్వేర్ డిఎక్స్ స్క్వేర్ అండర్ రూట్ ఆఫ్ పై బై ఏ అనేది ఫార్ములాలో 2 ఫార్ములా సబ్స్టిట్యూట్ చేస్తే మనకు ఆన్సర్ ఏమొచ్చింది? ఆఫ్ కేటీ వచ్చేసింది. సో దిస్ ఈస్ ద లా ఆఫ్ ఈక్వి పార్టిషన్ ఆఫ్ ఎనర్జీ ఇన్ ద క్లాసికల్ స్టాటిస్టికల్ మెకానిక్స్. నెక్స్ట్ మనకి ఇంకొకటి ఉన్నది, రిలేషన్ బిట్వీన్ థర్మోడైనమిక్స్. ఇందులో లాస్ట్ టాపిక్, రిలేషన్ బిట్వీన్ థర్మోడైనమిక్స్ అండ్ స్టాటిస్టికల్ అండ్ స్టాటిస్టికల్ క్వాంటిటీస్. సో ఇక్కడ మనం ఈ ఈక్వేషన్ ఏం సింప్లిఫై చేద్దాం? ఇక్కడ మనకు ఎంట్రోపీకి, ఎనర్జీకి, టెంపరేచర్ కి రిలేషన్ అనమాట. ఇక్కడ ఎస్ అంటే ఏంటి? ఎస్ ఇస్ ఎంట్రోపీ. ఈ అంటే ఏంటి? ఇక్కడ మనకి ఈజ్ ఎనర్జీ. టీ అంటే ఇక్కడ టీ ఈజ్ టెంపరేచర్. Using these three, we have one relation. What is the relation we have? 1/t equal to, what is the equation we have? 1/t equal to dou s by dou e. Now only I am taking LHS part. What we have in LHS? LHS we have one. LHS, what we have in LHS? We have 1/t. First I am simplifying LHS and equating to the RHS part. Here LHS I am taking 1/t equal to k beta. LHS ఏం తీసుకుంటున్నాం? 1/t equal to k beta. In place of beta I am substituting k times of, in place of beta, dou by dou e of log w. Dou by dou e of log w. So equate these two equations. Equate in place of 1/t, in place of 1/t, right? LHS lo రాయాలి. In place of 1/tau I am writing K times of dou by dou E of log W equal to ఇక్కడ మనకి ఏముంది dou S by dou E ఉంది dou S by dou E ఉంది dou S by dou E ఉంది. So here integrating the above equation dou S by dou E we are with respect to E dou S by dou E is writing as S. K is a constant as it right. Dou by dou E of log W I am taking as log W. So final answer is S equal to K times of log W. So here what is S? What is W? S is the entropy. W is the probability here. Here W is in the beginning first slide we saw. What is W? W is probability function here. So here this is the relation between the entropy and probability is S equal to K log W. So here we took 1 by tau equal dou S by dou E and 1 by tau is written as K beta and equating we got this one. Next in the summary what are the topics we studied? First in the we saw about what is statistical and thermodynamics, how statistical and thermodynamics is related. For single particle what we are taking for so when we are taking here microscopic, when we are taking macroscopic is defined in the introduction part. Next phase space. Phase space is a three-dimensional space which we are taking in x coordinate, y coordinate, z coordinate. This xyz coordinate we are calling as a position coordinates. Next momentum coordinates is taking as a px, py, pz. Total it is 3 xyz1 px, py, pz. Total it is 6. So we are calling this as a 6-dimensional space. This 6-dimensional space is also called as K. So here what is mu space? What is gamma space? What is mu space? What is gamma space? Mu space means position xyz, px, py, pz is called as individual separate terms. xyz, px, py, pz is called as mu. 6-dimensional space is mu space. For n particles, this we wrote for only one particle x, y, z okati px, py, pz. This is for single particle is mu space. Suppose the same thing I am writing for n number of particles, then we will call this as the gamma space. So if I take a phase space diagram, individual cell is calling as a phase space point. What we will get? We will get some trajectory path. Next, what is constraint? Different types of constraints we discussed. Next we saw energy contribution epsilon equal to half times of kT. So next we saw entropy relation S is equals to K times of log W. Here in each unit, few definitions is there, just refer, it is useful these definitions. What is microscope? It is defined as the position and momentum coordinates. Position and momentum coordinates microscope తీసుకుంటున్నాము. Macroscope లో number of particles, volume, temperature, energy. Why we are considering all this? A single unit cell ni micro antam. Combination of micros ni macro antam ganka ivanni indiloki number of particles cover avutayi. Next phase space. XYZ, PX, PY, PZ యొక్క components ni phase space antam. A single cell ni phase point antam. What is constraints? Constraints means the restrictions given for performing operation. Next, equipartition principle means equal ga divide cheyadam anamata. Energy is divided equally. That is called as equipartition principle. Next, number of degrees of freedom ni F tho represent chestam. What is number of degrees of freedom definition? It is defined as the number of independent ways which we can operate. Number of different ways we can perform the operation, such as translational, rotational, vibrational spectra can be referred. Just we will see the some first 2 minutes. So yeah, we'll see. What is the probability? It is a mathematical concept is dealt to find out the number of events occurred. Next, probability distribution. In likelihood, equal or unequal way of distribution here. Values and likelihoods that random variables can take in a given age. So within the range, how many accessible states is possible? This is called probability distribution. Next, what is the difference between the quantum mechanics and classical mechanics? Also, atomic level, subatomic level studies is called as quantum. What is classical? Here we will study about the motion of the particles in everyday life. Motion. simple pendulum, all these things comes under classical. Microscopic, macroscopic. Single individual particle is micro. A group of particles together is called as macroscopic. So we completed unit 1 and 2. From this unit 1 and 2, just open your last page. Which questions is covered in page number 160, 165 page. First question, what are distinguishable in indistinguishable particles? One of the question, how many marks is this? 5 marks question ఒకటి వచ్చింది. ఒక essay question ఏమో explain about the microscopic and so one essay and one short from block 1 is covered. In the next class, we will see about in the next class, tomorrow class, we will see a block 2. So, thank you, class completed.
Thank you, ma'am.